Good afternoon, ladies and gentlemen. My name is Godwin, and I'm chairman of Lurch Bates in Europe. We are the world's largest firm of independent elevator consultants. It's an honor to be here today to have the opportunity to tell you, in the short space of time available, something about the great strides we have made in modeling and simulating elevator systems, as well as our concept designs for multi-elevator systems. These revolutionary designs include Vertrack, which enables multiple elevators to travel in one shaft vertically, and Skytrak, which ultimately allows cars to travel along curved trajectories. Such designs will not only afford a quantum increase in elevatoring efficiency in tall buildings, but will also enable architects to embrace a new degree of freedom for vertical transportation, something they've had to wait about 150 years for. Skytrak is already prize-winning for its innovation and was recently explored in an interview I held with Discovery Channel concerning the future of vertical transportation in buildings. The series as a whole focused on urbanism and architecture in the 21st century and how our cities might develop to respond to increasing urbanization. As Eugene Cohn of Cohn Peterson Fox pronounced when first seeing Skytrak, "Adrian, this is very exciting, and you can quote me on that." Anyway, before we get into Skytrak, let's set things in context. I like simplicity of purpose, and many years ago I came up with the acronym SPACE, each letter having a meaning in the context of playing the role of elevator consultant for new buildings. You can see those set out in the slide here, and perhaps it's not a coincidence that the first goal is space take, emphasizing that our role is primarily to find ways to minimize the space take of the elevator system whilst ensuring traffic performance is met, architectural fit is respected, capital cost is minimized, and ease of use is maintained for tenants and individual building users. The taller the building, the more likely it is that there have had to be compromises made, albeit sometimes only small ones, in attempting to meet all the goals I just set out. The fact is that Lurch Bates has planned and executed the elevatoring for more tall buildings than any other organization in the world, and each one comes with its own unique challenges. Compromises, as I said, should generally be small, and if you start out with the right experience, you have a good head start at knowing the ideal locations for sky lobbies and the likely most efficient grouping and zoning arrangements given overall building and typical floor populations, etc. Nevertheless, because all the elevator industry's analysis software generally only focuses on one zone or group of elevators at a time, the question arises, has there been enough time to identify all the potential solutions, yet alone analyze them? Possibly not. Has there been enough time to develop the design integrally with other building services? Possibly not. I've set out here some of the latest trends we have adopted when it comes to minimizing space take in high-rise buildings. Some of the ones at the top of the list, like destination double-deck or 3D technology, I started planning into buildings like the 310-meter Shard in London over 10 years ago. That building is just this year being completed. This serves to remind one that you must be forward-thinking with technology and be able to anticipate what will be achievable within the timescale of the project to the benefit of the client and building. I want to concentrate in this paper, however, on the three more future-oriented topics at the bottom of the slide. I certainly see all of these as more than feasible within the short term. When we're talking about space take, of course, at one level, it comes down to some pretty simple rules that most architects, certainly who deal with tall buildings, already understand. But just to give everyone an idea of how these core planning decisions impact building value, let's look at a 10-floor building. Simply by planning a 4-car group serving 10 floors as an inline arrangement instead of an opposite entrance configuration could, say at £10,000 per square metre in the City of London, lose you £1 million of end building value. When it comes to 100-floor plus buildings, we're concerned about strategic core planning, leading ultimately down to millimetres of shaft plan space, divider beam design, lobby dimensioning, shaft construction, and not least about the minimum number of lifts required and whether we have found the optimal elevatoring solution. What I define as optimal elevatoring is set out here. It goes a long way towards meeting those space goals I mentioned at the beginning. Six years ago, I decided that our simulation capabilities that had their genesis in the 1970s at Manchester University with my father and Dr. Barney were well overdue for a radical overhaul, and not least to make better use of the computing power now available to all. It was in 2006 that we started a knowledge transfer partnership with Kingston University with these goals in mind. My vision for what we subsequently nicknamed Simulo was pretty ambitious, but after some early setbacks started to come together. It was a very long and time-consuming process to transfer all the knowledge and then the user requirements of the application to a programming team that had started out with zero knowledge of elevators and how systems operated. As you can see, the new application with simulation, visualization, and IFC output file is quite revolutionary in that it enables you to potentially design the vertical transportation for a building within a few hours, outputting reports on its performance, a visualization of the elevators in use, and an industry-standard IFC file output, BIM, of the elevators ready to be inserted into the architect's BIM for the building. Have we finished developing Simulo? Well, no. We are now expanding the expert system to identify the optimum floor for a sky lobby or series of sky lobbies for super tall buildings. We're also adding in the various other types of elevators and escalators in the building so that you can visualize the entire vertical transportation in operation in one model. We're also adding in all the associated information for the rest of the building design team, such as structural and electrical loads, etc. I would like to show you, using a mix of slides and videos, the capabilities of Simulo. It is a web-based application, so clients and consultants log in online. This is the single input screen for the expert system. On the left, you set up the building tenancy type and range of floors covered. On the right, you set up your target design criteria for up-peak, down-peak, and lunchtime traffic. Other information is requested, such as the value of each square meter of building space and the preferred arrangement of groups of elevators. In the center column, you have elevator-related variables, such as what car capacities are acceptable, what numbers of elevators in each group would be acceptable, and so on. You can then run the expert system, and you get a progress bar indicating how long it will take to analyze all the potential solutions. Because the expert system runs hundreds of options and hundreds of hours of simulation, you can be certain you have an optimal elevatoring solution tailored for your building. Simulo doesn't work like conventional traffic analysis programs that only study one zone of lifts at a time. It looks at entire tenancies and provides the most efficient zoning solutions. This groundbreaking application is unique to Simulo. You don't even need to have any experience as an elevator consultant to be able to use the application and take benefit from its enormous computing power. Here is part of the output table generated by the expert system. The green lines in the table indicate solutions that met the design criteria set. As you can see, for the 30-floor building being analysed, the expert system has reviewed 1,126 potential solutions. Here are the solutions that did meet the design criteria, and as you can see, perhaps surprisingly, there are quite a few. Therefore, they are sorted to identify the most space efficient, with the optimal solution at the top of the list. As it happens, a 666 single-deck low, mid, and high zone arrangement is identified as the optimal elevatoring solution. Extensive reports and graphs are available to download, confirming the proposed solution's performance. The solution then populates a project file, which enables the designer to access and modify any of the associated variables. All the data is pulled from a background database on conventional and machine roomless lifts maintained by our design department. Here you can see the elevator car and its dimensions, the shaft dimensions, pit depth and machine room height, the door dimensions and door performance criteria, the individual lift dynamics and performance criteria, the passenger data and traffic profile, floor-to-floor dimensions and populations, and finally, the group details, including arrangement of cars, lobby width, the surrounding shaft, wall dimensions, etc. With all this information held on the elevator solution within the application, a BIM output model can be downloaded by simply clicking on this button. Well, here hopefully is a video of the BIM output for our 30-floor building, where you can see the 3 zones of 6 elevators serving the building. You can also see the variable pit depths based upon the lift speeds. The output BIM file currently contains about 24 key components. We are still adding further components, but are getting close to a final generic elevator installation. Once an elevator contractor has been selected, this generic BIM can in turn be replaced by a manufacturer's BIM, thus maintaining the overall building BIM throughout the construction process. You can see the machine rooms with the winding machines and associated supporting steelwork, overhead lifting beams, control panels, machine room access door, overspeed governors, and power isolators. Within the lift shafts, you can see the landing entrance doors, the car and counterweight guide rails, the shaft dividing beams, the shaft lighting, the elevator cars with car top guardrails, and within the lift pits, you can see the buffers, the pit ladders, and even the governor return pulley. So I trust you will agree, already a fairly complete and accurately dimensioned elevator BIM that is compatible with all 3D architectural packages and downloads in less than 60 seconds from Simulo. For architects, it means being able to get a fully dimensioned 3D BIM of the optimal elevatoring solution within minutes of entering building population data, massively speeding up the design timescale, literally from months to minutes. Could we run the second? Yeah, let's. Okay. The other unique feature of Simulo is its capability to visualize the traffic simulation online. The visual simulation can then be downloaded and recorded as a video file. Here is an output video of our 30-floor building with its 3 zones of 6 elevators clearly depicted. We are running the up-peak traffic scenario with all passengers arriving at the main lobby. The virtual intending passengers change color from green to yellow and finally to red, depending on their waiting time. The visualization tool enables the user to fly through the building, observing lobbies and even traveling with passengers within cars themselves, because Simulo has the unique capability to view the entire building elevator traffic in operation simultaneously. It makes for a great analytical tool to pinpoint hotspots where there might be excessive queues or extended waiting times in all types of traffic situations. Again, this application is unique to Simulo. It is already capable of handling 250-floor buildings, and there's no limitation on the number of elevators that can be held within the model. Well, let's talk let's talk about the future. And here you can see the subtle difference between what we call Vertrack and Skytrak. With Skytrak, one is able to move away from the purely vertical plane, albeit the essential drive technology is identical, and we're fundamentally talking in both cases about delivering an elevator shaft in the form of a continuous loop. Within each loop, multiple cars can circulate, driven by a linear motor with permanent magnet assemblies mounted on the traveling car frame. Such a design must, by necessity, dispense with ropes, counterweights, and safety gears upon which the elevator industry has depended for the last 150 years. Let's start by describing Vertrack, which would in itself perhaps be described as a truly disruptive product for the elevator industry. When in operation, it utilizes two regular size elevator shafts side by side. One is an up shaft, the other a down shaft. The use of multiple cars in one shaft is the key to greater efficiency and reducing the footprint of the elevator core in tall buildings. Actually, our studies indicate Vertrack could offer significant payback and large value add to buildings as low as 30 floors. Here you can see the approximate quantum increase in efficiency that could be obtained by Vertrack over single and double deck type elevatoring. The diagram here indicates Vertrack would typically take 60% less space than a conventional single deck elevator solution. Let's look at a really simplistic example of how this technology would impact on building value when it comes to the super tall arena. Set out here, you can see that if we had a theoretical sky lobby 1,000 meters above ground with population of 2,000 to be serviced, we might need 8 high-speed double-deck elevators. Of course, with today's rope technology, we can't actually travel 1,000 meters vertically in one journey, so that would necessitate changing elevators perhaps halfway up the building. But bear with me. This is just to get a broad brush feel for the impact such technology could have. With Vertrack, we would only need 4 shafts, albeit with 9 cars located within each pair of shafts, thereby saving 4 shafts, and at just $5,000 per square meter value, that would add $50 million to the overall investment value of the building. And that's just from modifying how service to one sky lobby might be changed. The business case, therefore, for a product such as Vertrack, when it comes to super tall buildings, is almost overwhelming. Listed here are just some of the many benefits that could be afforded by Vertrack. Needless to say, enabling better net to gross makes super tall buildings in essence more sustainable, as we don't have to build so many to achieve the same amount of occupiable space. Other key benefits include unlimited vertical travel distances and potentially, with off-site fabrication of track sections, a much faster installation program. How does it work? Well, essentially, the pinched loop within which the cars travel in the adjacent up and down shafts is formed by using through cars with doors mounted on the front and back of the car. Cars are rotated through 180 degrees using a novel switch that's located at the extremes of vertical travel that keeps the car on the track at all times. Even if passengers decided to stay in the car during this process, they would not come to any harm. In this way, the tight tolerance air gaps required would be maintained without the need to take the car off the track and reposition it on another track. The mechanical simplicity of the invention means it can operate reliably, and the switches would be placed in the areas we currently define as lift pits and overhead space. At these locations, the lobby area required outside the planned space of the shafts themselves can be made available to make the transition between shafts. Of course, parking and servicing areas are introduced beyond the switches, so cars can be parked or taken offline for servicing without disrupting the ongoing flow of other cars around the loop. Here's a preliminary design for the track structure that incorporates the twin linear motor stators. On each side of the track, the guide rails, the power inverters local to the stator sections, the power distribution and data cabling are all held on board the track structure that sits between the two adjacent up and down shafts. Of course, much of the technology to enable Vertrack has been around for some years, but what has enabled such a design to become feasible has been the recent rapid advances in drive technology and the solution to the following key challenges that are integral to enabling elevators without ropes and counterweights. I don't have time now to discuss all of these in detail, but suffice to say, until we had invented these solutions, Vertrack and Skytrak would not have a real chance of ultimately turning into the commercial products we want to see for our clients. One of the solutions was to address the potentially large energy losses that could be incurred without countermeasures to losing the advantage of the counterweight. You can see in the video here, well, you might have been able to see that, we have already started to simulate the transfer of cars from a timing perspective between up and down shafts. In other words, we can really start to look at the passenger traffic performance of these systems and how they would perform in super tall buildings. Well, Skytrak is, I believe, what architects have been searching for almost as long as elevators have been around. That is to say, the dream of not having to travel in straight lines. I think the twisting, turning, sculpted towers we now see, after all, you can pour concrete and cut steel and glass to almost any shape and size you want, are the physical result of the frustration of architects who haven't yet been able to design and deliver buildings with radically different geometries, perhaps more like these. Here's my attempt at playing an architect. Once such new building geometries are feasible, then perhaps we can think about new building communities, about living in a loop. Imagine what it would be like to live just one elevator ride away from your work, your weekly shopping, a range of restaurants, your health club, or any other facility you might need. This would indeed be a green community. This short video depicts how a Skytrak cabin travels around a curved trajectory. As you will see, the entire cabin is able to rotate as the car travels in order to keep the car platform level at all times. Of course, for an instant, traveling in the car is like traveling on a bus or train, as the acceleration is purely horizontal. At other times, it's just like a regular elevator, where the accelerations felt are purely vertical. Yet again, at other times, it will be akin to traveling in an inclined elevator. There could be selective seating included in the car for passengers on relatively long journeys, and perhaps a lightweight glass window incorporated that could enable views from the car to outside the building to be gained. At the moment, we believe the minimum radius for the track is probably around 100 meters due to considerations of air gap, stator geometry, and other physical limitations. With multiple cars in one shaft, and even different cars for different types of users and uses on one track, there can be a variety of ways of planning a Skytrak vertical transportation solution for a building that can be both efficient and effective. As I mentioned earlier, the concept of Skytrak and circular transportation has already won the prestigious Lift Industry Prize for Innovation from the IAEE conference in 2010. Here is the proposed test track for Skytrak, needed for gaining the necessary safety authority approval. Of course, we anticipate working with major contractors to realize the first such installation for a client and architectural design team. The design work on Skytrak and component costing is considerably advanced. Here are all the key components of the Skytrak cabin, which, as you can see, are designed to ensure its all-up weight does not exceed the nominal 1,600 kilogram capacity car of the cabin, thereby limiting the maximum all-up load to about 3.2 tons. Fortunately, one area we hope not to make any changes to are the landing doors and entrances, which should remain the typical fire-rated type we currently use in the industry. And from the passenger's perspective, the booking of calls and the user interface should essentially be no different from today's experience, albeit the control software for allocating cars to hall calls will be radically different in the background. Well, in closing, I hope my paper has given you food for thought about how we can more effectively and more quickly plan vertical transportation in buildings going forward. The designs of Vertrack and Skytrak are significantly advanced, and we are currently courting serious inquiries involving futuristic building designs that could enable the realization of iconic landmark buildings of the future. Finally, here, courtesy of the Discovery Channel, is their version or attempt to visualize how a Skytrak system could impact the design of our future buildings.
El Skytrak. Se trata de un ascensor que se basa en el principio del giróscopo, manteniendo a los pasajeros de forma vertical, sin importar cuál sea su ángulo de inclinación.
This series of programs by Discovery Channel was really an exciting series done from South America, and looking at urban densification and building design for the 21st century. We see these types of systems as feasible within the next 2 to 3 years, and perhaps well before we see some of the flying transportation modes that Discovery Channel have associated with this little snippet. Thank you very much.